All right. Hi everyone. How are you guys doing? Hello Chinmay. How are you? All right, Chinmay. Can you let me know quickly if the volume is fine? If I'm audible? Can you hear me fine? Is the volume all right? Is the voice clear? Please let me know fast. All right. Okay. So first of all, let me welcome you guys to the Unacademy's JEE English. This is a brand new channel by Unacademy, which is India's largest online platform for IIT JEE. And in this channel, everything is taught to you completely in English so that the students who don't feel comfortable with Hindi being mixed in their lectures are feeling at ease here. All right. Hello, Priyanshu. How are you? All right, so before we start, let me introduce myself one more time for those of you who don't know me. So, my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. I've been teaching physics for JEE for almost 8 years now, wherein I have taught at some of the biggest institutes known for JEE. All right, so before this, I have been teaching offline only for the last 8 years. This is my first online venture with Unacademy. So, I myself was JEE rank 447. All right, and I've already coached many students to top ranks in JEE, and I hope to continue doing so with this new opportunity, with this new online platform, with you guys. All right, so hi Vaishnav, how are you? Moving forward, let's also talk about the Unacademy subscription and its benefits. Okay, so the Unacademy subscription comes with benefits like you have live classes, you get to interact with your educators. So both these are very important because they do not let you miss your offline setup, which obviously you're not going right now for. So obviously, so your studies do not hamper. Unacademy is providing you a very close to an offline classroom experience with its live classes. All right. So you have also live polls and leaderboards. So all these classes are kept interactive so that you don't feel that you're watching recorded videos. All right, you feel a part of the lecture and you're involved in discussion. And then there is test series and analysis, which is of course very important when it comes to self-assessment and when you want to improve your performance. All right, and you want to know where you stand. And biggest of all, you have live doubt clearing sessions, so which is a very big boost. All right, I know these days you guys are stuck at home. You don't know where to go for your doubts. All right, so you can join the Unacademy courses. So their live doubt clearing sessions are a compulsory feature of every course. All right. So after every 3 classes for a lecture, every teacher is supposed to conduct a live doubt clearing class. So that will really help you. Hi Raghavendra, hello Pavan, how are you guys? All right. So, and on top of everything else, hello Krishna, long time. On top of everything else, you are getting access to India's best educators with this single subscription. So I hope you realize that the benefits that this subscription has are huge. So how do you get this subscription? So it is very easy. First, you install the Unacademy app. Once you have installed the app, then go to the plus section. In the plus section, select your goal as IIT JEE and then click on that get subscription button. All right. Now, when you're getting your subscriptions, you will notice that the fees is very affordable. All right, so 12-month subscription comes at around 2,500 per month, and 24-month subscription comes at about 1,500 per month. So if you see the fees that you will be paying for these subscriptions, this is nothing compared to what you guys pay for your offline setups. And as I said, Unacademy is providing you an experience which is very close to your offline setup, which has almost the similar efficiency. All right, so you won't feel the difference. And the content here is high quality content. The teachers here are one of the best teachers in the country. So getting all that for this kind of price, I think it's a must to have. All right. So this subscription, according to me, is a must have. Should definitely try it for these prices. I mean, you shouldn't miss it. So when you're getting this subscription, please remember to use my code RDLive. All right. This code will also get you an additional 10% discount. All right. So this already affordable subscription fee will be made more affordable. All right. All right. So if you guys are following us on the JEE English channel, please connect with us on these links shown above so that you're getting notifications of all the sessions and classes which are happening on the JEE English channel. Alright, so yes, a lot of people have been waiting, so why don't we get started with the topic of the day? Alright, okay, so did I miss anyone's messages? Okay, Priyanshu is there. Yes, I said hello to him. Vaishnav, hi to you as well. Alright, Pawan, Raghavendra. Pavan, long time. Alright, and Krishna, also after coming after a long time. Alright, no problem, Krishna. I'm really assured that this session will help you, even if you've studied kinematics once before. All right. So today we'll be talking about relative motion. So what is relative motion? So first of all, we need to talk about moving reference frames. So whenever any motion is described, till now, whenever we were talking about any motion, whenever we were talking about the velocities, the accelerations, the displacements, we were talking about those in the reference frame of an observer which was stationary with respect to ground. So all these velocities, all these analysis was being done in the ground frame. All right, by default, if nothing is mentioned to you, if somebody just says the velocity of a car is 5 meter per second, that just means that the velocity of the car is 5 meter per second with respect to the ground, or with respect to someone who's stationary at the ground. All right. So obviously, I discussed this in the first class also. Why are we doing this? That so that we can describe the motion easily. Why? Because every observer inherently sees motion differently. So to keep a common description, we needed a common reference point to describe motion, and that common reference point was chosen as ground. Now in this section, however, though we have been describing motion through a common reference point, now we want to see that if I know something about the motion about ground, can I figure out what another observer who's not stationary with respect to ground, what he must be seeing? So the aim is to figure out how different observers are looking at motions of one thing, and these guys are not stationary now. All right. Unacademy is launching 9-day revision course in which Chitrang Murdia is teaching. Okay. All right. So that must be his own course. Okay. Anyhow, so as we were saying, so the aim is in relative motion, we are trying to describe the same motion as seen by an observer that is moving and may or may not even be accelerating with respect to ground. So this is observer. All right. So I hope you remember. Let me remind you what we used to say, that every observer essentially is describing everything, every position with respect to a reference point which he takes with himself. All right. So he keeps himself at 0, 0. He has a set of y and x coordinate axes, and he is moving everywhere with this reference frame. This is a reference frame. All right. Hi, Sujil. So imagine if there was a box here, and imagine this box was at a distance of d from the observer. Now, what happens if the observer is, and this box is stationary with respect to ground, but the observer is moving. So after a time t, the observer would have reached a distance vt forward. All right, and when now if he looks at the box, he would have said that earlier he sees the coordinates of the box as, this guy says, box at d, 0. All right, and after t, hi Samarjit, next chapter will be NLM. Yes, of course, next chapter is NLM. And from here, when he's looking at the same box, now what does he say? He says that the coordinates of the box are d minus vt, 0. All right, and what about himself? He always says that I was earlier at the origin, I am still at the origin. So what conclusion does he make? He makes a conclusion that, okay, I was earlier also at the origin, I'm still at the origin, so I never moved. However, the box was earlier at a distance d from me, and it has now reduced its distance. So he will say that the box is coming towards him with a speed v. That is what relative motion is. All right. The motion of the box as seen by the observer. It does not matter what the box was actually doing. What we will be dealing with is what this guy will see. So this guy in this case sees that the box is coming towards him with a constant speed v. Alright, so here is another example. So we have a person A who's moving here with 4 meter per second, a person C, alright, which is stationary, and a person B which is moving here with 3 meter per second. So when I ask B how he sees A and C, let's see how he describes this. So when I ask B what can he see, so B sees that okay, I am stationary. So B will feel that he is stationary. And see, what the trick is that if you have this velocity and when you are moving into the reference frame of B, so add a negative of this velocity to everybody. Those will be the new velocities in the reference frame of B. So in the reference frame of B, if this guy had 3 here and I add minus 3 here, so this velocity becomes 0. Similarly, how about C? C had initially C had a velocity of 0, but I add a velocity of 3 here. So B will see that 3 is moving in this direction with 3 meter per second. Similarly, what happens to A? A now, of course, is still running, but this guy will be running with 7 now. Alright. So in everything that you're observing, you add a velocity which was minus of velocity of B, and then you find the new velocities. Alright. So B would have described both C and A to be moving with different velocities. Now he would say that C is going in this direction with 3 and A is going in this direction with 7. Alright, I hope you guys are getting what I'm saying. This is what B will see. Alright, now since motion is always relative, different observers will describe the same motion differently. Hi Vinny, good to see you again. So please notice that every observer will have a different description of the motion. Alright, they might not even see the same motion, and it is alright. See, that is the thing which will be very counterintuitive and very confusing to you. That you will be told that one observer is looking and seeing something and another observer is seeing something completely different. And that is the thing that you have to accept. That is what actually happens. Alright. Now, what is the use of relative motion? When I know all the motions were being described in the ground frame only, why do I need this analysis? Why do I need to understand how moving reference frames are seeing things, or how moving observers are seeing things? So there are two distinct advantages. I mean, one, sometimes you may be forced to give your answer in a particular reference frame. Alright, so for instance, I'll tell you, there was this question in IIT. There they said that there's a disk, there's a track inside the disk. So okay, there was a groove inside the disk, and some particle was moving. Alright, and this disk was accelerating with A. Now you were supposed to answer the speed of the particle from the reference frame of the disk. Okay. Sir, I used to watch your lectures. I had seen him doing that yesterday. Doing who what? Oh, your sir was watching my lectures. Okay. Okay, it's anybody who wants help, it's okay. And okay, so that might be the case. Okay, sometimes the motion is asked to be described in a particular reference frame. Then obviously you have no choice but to analyze the motion in a moving reference frame. Second huge thing which you will realize after a lot of practices, that very often, if you can switch your reference frame wisely, then problem solving will get really, really easy. Okay. So how did he even know about my lectures, by the way? Did he see you watching them? Alright. So let's move forward. Okay, so let's talk about the mathematics of relative motion. So here I am starting from a very simple point. So suppose every motion was described earlier from the ground frame. So obviously there must have been an origin. So I'm taking this as the origin from the ground frame. Alright. And I'm imagining everything is being described about this point. So let's talk about two people or two particles. So particle A is somewhere here and particle B is here. So how do you make position vectors? You will have a vector originating from O going to A. This will be the position vector of A with respect to O. Similarly, this would be the position vector of B with respect to O. Alright. I hope everybody knows what position vectors are. Position vectors are vectors pointing from the origin to the position of any particle. Alright. Now what I need to say is, if, okay, okay, all right. Suppose what happens is that somebody asks, how will A describe the position of B? So it is very simple. However, whenever you're supposed to make, okay, I should let's just focus back on the lecture. All right, Vinny. Okay, you're distracting me. Anyhow, so whenever A is asked to define the position vector of B, so what will A do? A has its own coordinate system. So please remember this. Every observer has their own coordinate system which they carry with themselves, and they will always describe everything with respect to that. Alright. When I am asked where is something, so I will look at the thing and I will describe, okay, it is in this direction at this distance, right? So that is what we are going to do. So when A is asked to describe the position of B, so the position vector of B with respect to A would be a vector which will start from the position of A, it will go to the position of B. Alright, this is called the position vector of B with respect to A. Now, let's look at this triangle. If you look at this triangle, what can you see? Alright, so there is one vector like this. Okay, so this is one vector. There is another vector which is going in the other way. Alright, this vector. So you realize the sum of these two vectors. What is the sum of these two vectors? It's this, the third vector. Alright. If you remember your triangle laws, if you added these two vectors, you will get the third vector there. So just using that, I can write, using this relation, what can I see? I can see that this vector plus this vector is equal to this vector, which means R of A with respect to O plus R of B with respect to A is nothing but R of B with respect to O. Alright. So now as a common terminology or a common convention, what we do is we don't write this O every time. We understand if RA is given, RA by default is from the ground frame only. So that is why you have this expression. You take this term here and you will get R of B with respect to A is R of B minus R of A. So position vector of B with respect to A would be position vector of B minus position vector of A. Similarly, if somebody had asked me the other way around, what would have been the position vector of A with respect to B? Okay, so what would that be? Similarly, position vector of A with respect to B, this would have been position vector of A minus position vector of B. Alright, so position vector of the person is written first and then minus position vector of the observer is written next. Okay, that is how you do it. Alright, next, relative velocity. So this is called the relative position. Okay, this position vector is called the relative position of B with respect to A. Now if I differentiate both these sides, with respect to time, what will I get? I'll get the relative velocity of B with respect to A. So let's differentiate. So if I differentiate this, I will have velocity of B with respect to A, which will be velocity of B vector minus velocity of A vector. Alright, very easy, very simple. All I did was differentiate both the sides with respect to time. Next, to find relative acceleration, what do I need to do? I can differentiate this equation one more time and I'll get the relative accelerations. So relative acceleration of B with respect to A would be acceleration of B minus acceleration of A. Alright, so these are the vector relations between the relative vectors and the vectors with respect to ground. Alright, now interestingly, you can see one thing. When you are in the reference frame of A, what does that mean? That means that you are describing everything as seen by A. So let us see something. What is the position vector of A with respect to A? It will be RA minus RA. So it will be 0, which is obvious. Why? Because A, wherever he goes, he is carrying all these axes with him. So if I am moving somewhere, I am moving with these axes with me. So whenever I go, I will always remain at the origin. So my position vector will always be a null vector. Similarly, what is the velocity of A with respect to A? So what is the velocity of A as seen by A? Obviously, it will be 0 also. Alright. Again, why? How do you describe motion? You look at something and you see if the distance of that thing is changing from you, then you say it is moving. So when you look at yourself, your distance from you will never change. Alright. Can you repeat? I didn't understand which part, Chinmay. Which part are you talking about? Which part? Similarly, let me just finish this and then I will get to what you were saying. Acceleration of A with respect to A would be acceleration of A minus acceleration of A, which is again 0. Alright. So no observer will ever realize his own motion. Alright, every observer will think, okay, I am always at the origin, my velocity is always 0, my acceleration is always 0. Alright, so whenever describing motion, an observer will never see his or her own acceleration, never see his or her own velocity, and never see any change in his or her own position. He will always think that he is at the origin only. Now, Chinmay, if you can tell me which part you didn't understand, maybe I'll repeat that. Which part exactly, Chinmay? If you could quickly write, then I will take that over. Okay, till the time Chinmay responds, let me tell you one more thing. Moving reference frame. So what we are doing is in relative motion, we are doing the entire analysis from a moving reference frame. Now, moving reference frames may be of two types, translating and rotating. Now, in JEE syllabus, you only have translating reference frames, by the way. Relative position and velocity and acceleration in simple way. Uh, okay, I don't know, in simple way. Did you follow this relation? Did you follow this? Okay. All I am saying is that this is always going to be the relation, this kind of relation. So if you have to describe velocity of, okay, so if you followed this, then from here I just took the other thing here and we wrote this. All I meant was, I was saying was that we do not write this every time. It is understood. It is understood that if RB is written, then R of B is with respect to ground. If nothing is written with respect to what, then it is understood it is with respect to ground. So these are with respect to ground. Okay. So that is what I was saying. That with respect to ground, you do not denote with respect to this, with respect to that. With respect to A, you have to write it like this. I did not add /0. Okay. Okay, don't worry, don't worry. We will take that up next. Alright. So all I was saying is that this is already default understood with respect to ground. That is what I was saying. Okay. That is it. I was saying if nothing is written here, if nothing is written with a slash, then that means this thing is with respect to ground. That is just the standard notation, standard way of writing. Okay. This is just the standard way of writing. If I write RB, that means from with respect to ground only. Similarly, if I differentiate this equation, I hope you know what differentiation is, Chinmay. Do you know what differentiation is? If I differentiate this, both the sides with respect to time, I will get this. You differentiate this with respect to time. Okay, so that was the problem. That is why you did not get how I wrote this. Okay. And differentiate this with respect to time. Alright, so what you'll have to do is you'll have to watch my previous lectures. Watch a basic maths lecture that I took. Okay. I took 2 basic maths lectures wherein I have explained what differentiation is, what integration is. I mean, only the basics. Okay. So you watch that and then you won't have a problem. Alright. Now, as I was saying, Whenever we talk about a moving reference frame, there are usually two kinds of moving reference frames. One is called a translating frame. So what is happening in a translating frame is, suppose you have this X, this Y. So in a translating frame, whenever observer is going, the orientation of the axis is never changing. Only the origin is moving here and there. So it may be moving like this, it may even be moving in a circle. So this is a translating reference frame if your origin only translates and your axes do not change their orientations. Okay. So observer, even if observer was moving in a circle, the orientation of the axes would remain the same. Please remember this. That is what translating reference frame are, and that is the limitation of JEE syllabus. JEE syllabus only talks about translating reference frame, not about a rotating reference frame. In a rotating reference frame, what happens is that when the observer is rotating, then this guy also starts rotating. Alright, this is a rotating reference frame. When the origin is not moving, but your axes are turning. Alright, so that is not in JEE syllabus, by the way. Rotating frames are not in JEE syllabus. Alright. You will realize that the problem is that the mathematics is slightly difficult for this. That is why it is not in your JEE syllabus. Though you can study small bits of it, there is a coordinate system called the polar coordinate system that is used to describe these rotating motion in rotating reference frames. So r theta system. But then it's best to avoid that for now, and let's just stick to the simple things that we know. All right. Now let's try to visualize relative motion. So what is relative motion? Why I'm saying that every observer will see things differently. So look at this. If this guy was in a moving cart, so how does he see himself? He sees himself to be stationary because his position is not changing with his surroundings. So when he looks at the ground, he is stationary with respect to the ground. When he looks at the wall, he is stationary with respect to the wall. But an observer which is standing outside will say that no, you are moving. So both these observers will describe their own motions differently. Alright, this will say I am stationary, this will say you are moving. Alright, next let's take another visualization. Imagine there is a train. This train is moving forward and there is a person who's inside the train, and what he does is he launches a ball vertically upwards. So a person standing in a moving train throws a ball vertically upwards. Now it turns out this is what he will see. He will see the motion of the ball as perfectly up and down, and this guy will see that the ball went in a projectile. Alright, let's understand how. So what is happening is, when you're inside the train, from your reference frame, what you notice is that the ball went up and it straight came down. Alright, because you yourself did not change your position. When you are looking at yourself, you did not change your position. So obviously if the ball went up and is coming back, so I will see that the ball is also going up and down perfectly in a straight line. No, JEE syllabus is not reduced. As far as I know, it hasn't. Okay. Now for outside the train, the ball appears to be going faster. Why? Because when the ball was thrown up, it would have been thrown like this. So it would go like this. And by the time it comes back, you would have moved ahead. Alright, so the ball would have come like this. That is what you will see outside of the train. Alright, that is the kind of trajectory you will see. The initial velocity, what you will see is, this person gave it an initial velocity of this, in this direction. This person himself was moving like this. So you will see that both the velocities will be a part of the velocity of the ball as seen from the ground. So as seen from the ground, the actual speed of the ball would be faster. Alright, so if the person throws it up, the person is also moving forward, so he will also automatically have given this velocity. Alright, imagine even if the person doesn't throw this, and the person is moving ahead with some v, so the ball is already moving ahead with v. I hope you realize, because the person is stationary, and even if the person is just holding the ball already has a forward velocity. Now if the person pushes it up, then the ball will end up having both these velocities, and in the air it will move like this. Alright, and the faster the train moves, the faster the ball will appear to be moving to an outside observer. So for the inside observer, everything will remain the same. If he is giving some velocity, let's say v, then he will always see v velocity only irrespective of what is the speed of the train. He will not find a difference in the speed of the ball. Even if, let's say, the train was moving with 10 meter per second or 20 meter per second or 50 meter per second. However, when an observer is looking at the same thing from outside, he will see, okay, this has an initial velocity which is equal to the velocity of the train. So he will see the net velocity to be sum of these two. So obviously, if this is more, then he will think that the ball was launched with more velocity. All right, I hope you can understand that. Please let me know if you understood the logic. Let me know if you understood the logic. If there is any confusion, then I will repeat that point again. Okay. I hope everyone is following the logic of the discussion. All right, great. Next, let's see another visualization. Okay, so imagine a plane is going and he's throwing a packet. So let's see how they are being observed. Now let's take a look at the motion. This is what two people will see. All right, so this is what the ground person will end up seeing. The ground person sees this, and this guy, you see, this is always right below. The pilot can always see the particle. So the particle is always below him only and moving downwards. All right, so the pilot can see the box moving right below him. And he thinks that this guy on the ground is coming backwards. That is what the pilot will see. The ground observer will see that the plane is moving, the packet is moving like this, but the pilot can see that the packet is just falling like this. The entire ground is coming backwards. The entire ground is moving backwards. All right. I hope you can see this. So this is the pilot's view, and this is the ground observer's view. All right. Everybody clear about this? Can you visualize it now? How two people are viewing the same thing differently. All right. One sees a projectile motion, another sees a straight line motion. Okay. All right. Next, let's take up another example. Good afternoon, Krunal. How are you? All right, let's take up another example then. So in this example, you're talking about a boat. The boat is trying to swim like this, and in a river which is flowing in this direction, the boat will end up swimming like this when seen from the ground. Now let's see what is happening. Let us talk about two observers. One which is in the river, which is floating in the river. So what is happening to that observer? So imagine, okay, so there is this guy. One guy is floating in the river. So floating means he will flow with the river as the river flows. So every time, if he has to describe, he will say, okay, the boat is here. Now, when the river is flowing, so he will also float with the river. All right. So when he reaches here, he would have seen that the boat would have reached here. So he will again say, okay, the boat is moving just perpendicular to me. All right. So when he reaches here, he will see the boat has reached there. So according to this observer, which is floating with the river or in the frame of the river, all right, what does he see? He sees the boat traveling in a straight line. That is what the person on the boat will also see. The person on the boat will see something different. Okay, he will see that the river is flowing back and he is trying to go the other side. Okay, so this is the motion of the boat in the reference frame of the river. From the reference frame of the river, it always seems that he is moving forward. Now, this velocity is called the velocity of the boat in still water. Why? How will water appear to this observer? This observer. The observer which is floating with the river will always see water as stationary. Because as the water moves forward, he is also moving forward with the water. So, such an observer will see water to be stationary. So, this is called the velocity of boat with respect to water, or velocity of the boat in still water. However, when a person from ground is noticing the same motion, what does he see? So an observer on the ground sees, okay, earlier you were here, then you try to move here, and river also shifted here. So because of this, you are moving one in this direction, because the boat itself has a velocity like this, and the river is moving, flowing in this direction. So he will feel that the net velocity is going, getting added up, and the boat ends up moving like this. Okay, maybe I can show you an example of that also. Okay, so let us see. Maybe I'll need a big surface. Okay, let me see if I have a book lying around. Yeah, I do. Okay. So yes, one of my favorite books. It's CV. Anyhow, so imagine this. So let's try and visualize this also. All right. So imagine that I am pushing this phone. I am pushing this phone in this direction. All right. So how do you see the motion? You see it in a straight line. And if this book is moving like this, then you see the phone moving in this direction. Now imagine if I do both these things. Now the phone is moving forward and also going towards the side. Okay. So now the phone would actually have moved in this direction. Okay. The phone was here. It ends up here. So it has moved in this direction also. It has moved forward also. So it has moved along this line from its original position. All right. So that is what will happen. Okay. In this case, if a boat is trying to move in this direction and the river is flowing, the boat will end up moving this in this direction as according to the observer on the ground. All right. I hope that is clear to everyone. Okay. I don't know what that is supposed to be. So why don't we try some maths now? Let's okay, enough of visualization, enough of understanding what relative motion is. Now let's start with the mathematical analysis, and let's try and see how we can solve the problems. So in this problem, you've been told a car P is moving towards east with a velocity 12 meter per second. Another car Q is moving towards north with a velocity 9 meter per second. All right, find the velocity of the car P observed by a person sitting in the car Q. Okay, I have no idea why that is the case. Maybe it's the laptop or the AC. Maybe I don't know. Anyhow, why don't you focus on the problem at hand? All right, let's see this problem. So car P is moving towards east. Yeah, try and ignore that, Doraemon. So car P is moving towards east with a velocity of 12 meter per second. Car Q is moving uh, towards north with a velocity of 9. Okay, so you have to find the velocity of car P observed as observed by a person sitting in car Q. So please try this problem, and you can write trying in the chat to let me know that you're trying. No, no, Chandrasekhar. Read the question carefully. They're not moving in the same direction. Okay, yes, why don't I do that? Very good. So, what does it say? It says car P is moving towards east with velocity this. Okay. So, what is the velocity vector of P? The velocity vector of P is towards east. Alright, I hope you remember your directions. So, this is north, south, east, west. Alright. So, this is the velocity vector of P. I can write it as 12 I cap. Or, yeah, the length is this and the direction is this. Alright. I hope you can see that. Similarly, what does it say? Another car Q is moving towards north with a velocity 9 meter per second. Alright. So, what is the velocity of Q? It is this 9 meter per second. Alright. This is velocity of Q. Alright, so if I had to write in vector forms, how can I write this? I can write VP vector as 12 I cap. Similarly, I can write VQ vector as 9J cap. Alright, now what are we supposed to find? Okay, 15 root 2. Okay, maybe. Yes, that may be the correct answer. So you're supposed to find the velocity of the car P as seen by an observer in car Q. So I am supposed to find velocity of P with respect to Q. What will that be? I know that will be VP vector minus VQ vector. So this is nothing but 12I cap minus 9J cap. Alright. I hope you can see that. You can either make a vector diagram also now. Alright. So what you can do is that you can have VP vector. So this is VP vector. And you can have minus VQ vector. So let's see what minus VQ vector is going to be. It is going to be like this. This is minus VQ vector. So the resultant would be this. So this would be velocity of P as seen by Q. Alright. Q will think that V is moving in this direction. P is moving in this direction. Ground person will say that P is moving in this direction. Q will say that P is moving in this direction. Okay. So yes, what is the magnitude of this? If I had to find the magnitude, it is very easy now. Magnitude of this would be root of 12 square plus 9 square. Alright, so 144 and 81. So what is that? That is root of 225. So where are you getting this? Okay, 40 plus 80 would be 120, 125. 225 only I'm getting, so 15 only. Why 15 over root 2? Square root of 15 is 225, right? So how are you getting different answers? Please check your calculations, guys. Yeah, exactly. That is what. You guys made some mistake. The relative velocity is 15 meter per second. Plus, of course, plus. You're talking about the magnitude. Magnitude. Whenever you mention magnitude, you always write plus. The minus is about the direction, but the direction here will be given by this vector. Okay, so please don't get confused about that. If you have to write the vector form, then you will specify either like this, or whenever you have to talk about the magnitude, magnitude is always positive. Alright, magnitude of any vector can never be negative, guys. Magnitudes are lengths of the vectors, alright. So either you represent it in vector form, or you can show it from here only directly, that in this direction. You could have calculated the angle also, by the way. So if this is angle theta, you know tan theta would be this over this. So theta can be written as tan inverse of VQ, which is 9 over 12. So that will be 3 over 4. Tan inverse 3 over 4 is nothing but 37 degrees. Alright. So it according to Q, P will move at an angle of 37 degrees south of east. Okay. With a speed of 15. Okay. No, no, tan inverse 3 over 4 is not this. Sorry. That is, yeah, it is this only. Yep. All right, understood. So either if the speed has been asked, okay, if the velocity has been asked, then you say this answer. If speed has been asked, then you say this answer. And angle, obviously, you can also say about the angle. This is 37 degrees south of east. Okay. This class will end in another half an hour. All right. So why don't we get some more practice then? So try this problem. This is just for getting practice. Okay. So man A is sitting in a car at rest. He observes a man B on a bike moving away from him in the plus x direction with a velocity of 16 meter per second. A man C is walking towards him with a velocity of 2 meter. Okay, so let's start calling these speeds, because the velocities would have the minus direction also. Let's just replace everywhere wherever you see velocity with speed. Because the direction has been mentioned separately, so these are the speeds actually. I don't know, probably, yeah, bird is flying with the speed, that is fine. Alright. Okay, no problem, Pranal. You can watch this later. Okay. And here also let's try and find the speeds only. Is it fine now? You have to find the final velocity, not velocity, speeds only. Just find the speeds. Or you can find the velocities as well. I mean, completely up to you. But also mention speeds. Find the velocities, also mention the speeds. Okay. So try this quick and write trying in the chat to let me know that you are trying this problem. Alright, please write trying in the chat so that I know you guys are trying. Okay, how about the other people? I hope others are also trying. So just use vectors, guys. Just use vectors. This is simple. This is nothing. Just remember vectors and just remember how we define relative velocities. Okay, that is it. All right. So does anyone have the answer for part A at least? Pawan, do you have the answer for part A? Okay, so he has all three answers. Okay, 16, 0, and so that is the velocity of the car, bird, and man C as seen by B. Okay. Okay. So these must be the answers for 1. Okay. I'm assuming. All right. So that is why I've given you so many parts. So by the time you solving for all the parts, I'm sure you should be fine. You should have a good understanding of how to calculate relative velocities. All right. Okay. Let's try the other parts. So first things you need to do is write everything in vector forms. Okay, with respect to ground, and then it's very easy. Once you have everything in vector form, then you start writing everything in VA minus VB form. Okay. All right. Okay. So Pawan says these are the answers for A and B. Okay. Let's see his answers for C. How about other people? Okay. So Pawan seems to have gotten all the three answers. How about others? No one else has got any answers. Yeah, I got that. I got that, Pawan. How about everyone else? Is anyone else going to give me an answer? Doraemon Singh, how about you? Chinmay, where did you get lost? See, this question has a lot of parts just so that you're writing so many relative velocities that you become absolutely familiar with it and you don't make any mistakes after this. So you have to write what? Nine relative velocities in this. So I'm sure if you have written nine relative velocities, then you will be sorted about how to write relative velocities. All right, no problem, Chinmay. Take your time. I will wait. Don't worry. Because it's very important that you guys should definitely try writing these on your own. And I hope everyone who's attending the lecture live has a proper notes copy for themselves. So always, whenever you are attending a live lecture, always sit with a pen and a paper. Always make notes, your own notes for the important points. Because as I had told you earlier, also when in my other video, how to make the most of online lectures, that I will be saying a lot more than what is written on these slides. All right. What is written in these slides is only the main points that I want to discuss. But a lot of explanations I'll be giving on my own. A lot of things I'll be saying will be much beyond what is written in the slide. So even if you download this later, if you don't have your notes to explain everything, then obviously it will not help you much. So it's always better to keep making your own notes while you're writing the lecture. So that whenever you want to revise, you can simply open the downloaded PDF, go through that, look at your notes, and just remember everything. In fact, that is what I think you should also do. You should always, after the lecture is over in the evening, go and have a revision of sorts, maybe the next day, wherein you download the PDF, go through the entire PDF, and look at your lecture notes and make sure that you are understanding everything. Okay. So, Chinmay, do you have any answers for parts A at least? Do you have any answers for part A? Because we have already taken enough time on this problem. I don't want to wait too long. So why don't I just start solving this? Okay, so let me just solve it, and then you can maybe do it on your own later, and maybe then you do need more practice. Okay, if you are still not able to write this. So first of all, a man is sitting in a car at rest. So what is the velocity of A? It's so complicated. No, it's not. It's not. What is the velocity of A? Velocity of A is 0. Why? Because I've been told that the man in the car is at rest. He observes a man B on a bike moving away from him in positive x direction with a speed of 16 meter per second. So how is B moving? It is very simple. B is moving in this direction with 16 meter per second. This is as seen by a person who's stationary on the ground. So this is the velocity of A with respect to ground. Velocity of B with respect to ground would be 16 I cap. Alright, this is what B is. Just break it into parts. Don't worry, Chinmay. Just look at every part one by one. He sees a man walking towards him with a velocity speed of 2 in the negative x direction. So what is C doing? Let's see. So C is moving towards A with a speed of 2 meter per second. Again, since A is stationary with respect to ground, so I can say that the velocity of C with respect to ground is minus 2 I cap. Alright. Now I'm taking the horizontal as the XY plane, by the way. Alright, I'm taking the horizontal as the XY plane, or I can take the horizontal as the I can take this vertical plane only as the XY plane, don't worry. Now let's talk about the bird. The bird is flying with a speed of 20 meter per second at an angle of 37 with the positive x direction. So the bird is moving. Let's see the motion of the bird now. So this is horizontal. The bird is moving at an angle with the horizontal, 37 degrees, alright, with a speed of 20 meter per second. So that is what the bird is doing. Again, this is as seen by A, and A is stationary with respect to the ground. So I can again break this into two components. This component would be 20 cos 37, and this component would be 20 sin 37. Alright, so I hope you know the values of sin 37 and cos 37. Cos 37 is 4 by 5. So this would be 20 into 4 by 5, which is 16. Okay, so this component is 16 meter per second. Similarly, this would be 20 into 3 over 5. So that will be 12. Alright. So the bird has two speeds, 12 and 16. So how can I write the velocity of bird vector in vector form? So velocity of bird vector would be 16 I cap plus 12 j cap. Alright, please let me know if you followed this. If you followed how I wrote different velocities for different people. Let me know, Chinmay. Did you follow this? Yes, Pawan. It is 4 by 5. Alright. Chinmay, quickly tell me if you followed this, how I am writing the different velocities. Yeah, I'm waiting for Chinmay to answer because he was getting confused the most. Alright. Now let's see what all I have been asked. So part A says the velocities of car, bird and C as seen by B. Alright. So for part A, I have been asked the velocities of A, C and bird as seen by B. So that is nothing. What is it? The velocity of car, which is the velocity of A, as seen by B would be velocity of A vector minus velocity of B vector. So all I need to do is start substituting these values. 0 minus 16 I cap. So this would be minus 16 I cap. Alright. So what will B see? B will say that the car is moving towards the negative x direction with a speed of 16 meter per second. So 16 meter per second in negative x. Alright, that is what we will see the car to be doing. Next, velocity of c with respect to b. That will be velocity of c vector minus velocity of b vector. Now velocity of c vector is minus 2 I cap. So it will be minus 2 I cap minus 16 I cap. So this will be minus 18 I cap. So it will appear to be moving with a speed of 80 meter per second in negative x. Alright. Similarly, now let's talk about the bird also. Velocity of bird as seen by b. This would be nothing but velocity of bird vector minus velocity of b vector, right? So let's write again. So this is 16 I cap plus 12 j cap minus velocity of b, which is 16 I cap. So it will be 12 j cap, which means this guy b will see the bird to be flying vertically upwards with a speed of 12 meter per second. So 12 meter per second vertically upwards. Alright, please let me know if you followed all these parts. Chinmay, did you follow all these? How we got all these parts? Please let me know. Ah, you neglected the direction. No problem, no problem. So the first answer would be 16, 18 and 12. Let's see what Pawan had given. Pawan, your part A answers were wrong. 16, 12 and 18. Alright. Now it is very, very simple. You do exactly this for part B and part C also. I hope you'll be able to do that. Alright. Now you can do that on your own. Okay. So very, very simple for part B. Everything has been asked with respect to C. So for part B, what you will start doing is, for part B, you will say velocity of man A with respect to C is velocity of A vector minus velocity of C vector and so on. You will simply substitute these values in different equations. Alright. Keep substituting these values in different equations and you will keep getting all your answers. Yeah, that is wrong. Why will you not see the motion of the bird in the vertical direction? You have to consider that. You cannot ignore that. Alright, so Chinmay, if you followed this, let me know if you will be able to solve the rest of the parts. It should be easy now. Alright. I hope you figured out how to solve the rest of the parts now. Are you still finding this confusing or is the confusion sorted? See, it is not complex at all. Is it complex? Please let me know. Okay. Trust me, you try it now, it'll be easy. Okay. Alright, so let's move ahead. Okay, so this is one problem that I wanted to show you to help you realize the how strong a concept of relative velocity can be in problem solving. Alright, so let's try this problem. Alright, now this is a complex problem. Slightly complex. Not really. This is an easy problem only. So what does this problem say? It says a motorboat is going downstream. It overcame going downstream, overcame a raft at a point A. T equals 60 minutes later, it turned back and after some time it passed the raft at a distance D equals 6 kilometers from point A. You have to find the river flow velocity assuming the duty of the engine to be constant. Let's try this. I mean, it's not necessary that you solve this with the relative motion, by the way. You can just simply solve this. Okay, this is a normal kinematics problem. Let's see if you can solve this. Oh, by the way, just FYI, not creating any pressure. So this is problem 1 in the book I think problems in general physics, or is it problems of general physics? Let me remember. Problems in general physics. Okay, I hope you guys have heard of this. Have you heard of this book? So this is the problem number 1 of that book. So today you are starting to solve the riddle. What do you think? What is a raft? The raft is freely floating. The raft is freely floating. That is why you see, that is why it will pass the raft at some other point. The raft is freely floating. You can assume the raft to be freely floating. Alright, freely floating raft. Freely floating means it's floating with the river. It'll just flow with the river. Alright. You could have considered it as a piece of wood floating in the river. Alright, so try this problem. Let's see if you can solve this. Yes, absolutely, Pawan. You said that right. So why don't you guys try this problem? Till then, let me get some water. I'm feeling thirsty. Okay, so let me get some water. I'll be back in 2 minutes. All right. Okay. Yes, in fact, velocity of 1 with respect to 2 is 3 kilometer per hour is the right answer, by the way, Chinmay. So how did you calculate this? Hi, Chinna. How did you calculate this, Chinmay? That is the correct answer, by the way. All right. You are right. The answer is 3 kilometer per hour. All right. So how do you solve this? Let's see the solution. Okay. So don't tell me you just looked at the answer from the back? Did you solve it or you just looked at the answer from the back? So did you actually solve this or not? Okay, that is. You're supposed to solve it, not look at the answer from the back. What's the point of that? Okay. All right. Hmm. So why don't you try? Pawan, are you trying? Let me know if you're trying. So whenever you want me to solve it, I can solve it. Let me know. All right. No problem. Keep trying. It would be convenient if you could zoom out. This is already zoomed out only. This is zoomed out. This is zoomed out only, Sabresh Kumar. You're not missing out anything. This is the entire problem. Okay? Don't worry. Yes. All right. Hurry up, guys. All right. So finally, Pawan got it. Great. All right. For the rest of you, let me solve this. I'll solve this using two methods. Okay. So let's see the two methods. All right. So first, let's see method number one. All right. Yeah. Okay. Great. So in method number one, what you do is you imagine that the boat which was had a sound velocity v with respect to the river. Let us assume that. See, let's look at the language carefully. What does it say? The engine, due to the engine is constant. What this implies is this means that the velocity of the boat with respect to river will remain constant. All right, that is what this thing means. All right. Yes, we will be using kinematics only. Don't worry, Pawan, in both the methods. So I am assuming that the motorboat can move with a speed v in the river with respect to river. So v being speed of boat with respect to river. All right. Now let us assume that this is your river. So the river flow is happening with the speed of u. All right. So let us imagine this was our point A. So this was point A, and here was your raft. So raft would be moving ahead with a velocity u. Okay. So this is point A. Now, what does the boat do? Let's see. So the question says the motorboat going downstream overcomes a raft at a point A, and then 60 minutes later it turns back, and after some time it passes the raft again at a distance d equals 6 kilometers. Okay. So what happens is now the boat would be moving. What would be the speed of the boat when it moves? The speed of the boat would be v plus u. This would be moving with v plus u. All right. And the raft would be moving with u. So first your boat will go ahead for 1 hour. So it is moving. Let's say it comes to some this point. So this is t equals 0. T equals 0, everybody is here. At t equals 60 minutes, this guy comes here. All right. And then it takes a turn. From here it takes a turn. Okay. So after taking a turn, it starts going back. Now while going back, what will be the speed? The speed would be v minus u. And when it is going back, it will reach some point here. And during this entire duration, please note that this guy will keep on moving with u only. So this keeps on moving with u for the entire duration. And let's say that they cross each other again at this point. And let's call this point point B. So this is B. All right. So what all do I know? I know that the distance AB is 6 kilometers. Okay. AB equals 6 kilometers. All right. Let's call this point C. The point from where the boat turns, let's call that C. All right. I hope that is everybody is fine with that. All right. Now let's start writing some equations. So what can I say? What will be the length AC? The length AC would be V plus U times 60. Okay, so that is the first equation that I can write. The second that I can write is CB. The length CB would be V minus U times some time t. I don't know what time t is. Time t is the time that it takes from getting from here to here. So time t is the time taken for coming back from C to B. Now in this entire duration, the raft was moving with U. So now I can say that AB would be U times 60 plus T. All right. I hope you guys can see that. Okay. Can you see all these equations? These are the ones that I can write for this. Okay, please let me know if you're following this. Are you fine with these equations? All right. Great. Okay, okay. Now what else can I do? Okay. Okay, now let's see. Let's see what else can we do. Okay. Now I can also say that AC minus CB would be AB. Alright, so what I can say from here is that 60V minus VT, okay, plus U times 60 plus T equals AB. Agreed? Can I write this? Because AC minus CB, that is AB. Alright, don't worry, don't worry. So now, I also know this. What is this? This is already AB. So from here, so this is 4. But if I notice from 3 that this is already AB. So from 3 and 4, I can say that 60V minus VT equals 0, which means T equals 60. Alright. So this is what I could conclude. That the time taken to come back is also 2 hours. Now it's very, very easy. Now it is very, very easy. Now I substitute this value over here. So that means 6 kilometer equals U times 2 hours. And therefore U equals 3 kilometer per hour. Alright. So let me know if you followed this solution. Let me know if you followed this solution. Did you guys follow this solution? Alright. Now let's talk about method number 2, which will be very, very quick. In method 2, what I'm going to do is I am going to look at the boat from the reference frame of the raft. Okay. So if we look at the boat from the reference frame of the raft, so what is the speed of boat while going downstream? It is V. What is the speed of the boat while going upstream? It is also V. So in method 2, look at the boat from the reference frame of the raft. Let's see what you will find. You will find that the raft is here. And what is the speed of raft? The speed of raft is 0. Okay, so V raft is 0. So the raft is stationary. The raft would be stationary. Okay. Now what about the boat? While going, V boat would be V. So it goes from here to here, and at t equals 60 it reaches here. Then it turns back. When it turns back, what is the V boat again? V boat is again V. So what are you seeing from the raft frame? The raft frame, what you see is that raft is stationary. The boat crossed the raft, moved with a speed V. Then after 1 hour, it turns back, comes back with a speed v. So you realize the distance as seen by the raft, if you call this distance x, this is also x. Now, since x by v equals 60, so the time taken for this, time taken while coming back is also 60. So from here to here, t is also 60. Alright, I hope you can see that from the reference frame of the raft, it is going a distance x with a speed v. It is coming back a distance x with a speed v. So if it took 1 hour to go away, it will take another 1 hour only to come back. So total time I already know. I essentially can straight away say that small t equals 60 from here. Once I can say that, now I know 6 kilometer equals u times 2 hours, which gives me u equals 3 kilometer per hour. Did you guys follow this method? Did you follow this method? Sir, I have provided minus u velocity to both objects, so I got raft is stationary, and now we can say we got t1 equals t2. Yes, absolutely. So the moment you move to the reference frame of the raft, the problem becomes very, very simple. You don't have to write any such equations. You immediately know if it took 1 hour to go away, it will take 1 hour to go back, come back. So you know it took a total of 2 hours to meet the raft again. And in this entire duration, the raft has moved a distance of 6 kilometers. Alright, in these 2 hours, the raft has moved a distance of 6 kilometers. So raft must be moving with a speed of 3 kilometers per hour. That's it. Alright. So this is a very powerful tool of problem solving. Alright. If you can switch your reference frame correctly, then you realize that the solution is not only shorter, the the number of equations is also very, very less. And you will get your answer very, very fast. Alright. Just that you should be able to visualize that. So that will require some practice. But once you are able to visualize it, visualize how motion is happening from different reference frames, trust me, this will be very, very easy. Alright, so that is it for today. I think we should wrap it up here. Next time we'll discuss about special cases of relative motion. So you guys know that there are few special cases that we discuss separately. Those special cases are like riverboat problems. Then you have rainman problems. So these problems, these special type of problems we'll discuss tomorrow. So I hope you enjoyed your introduction to relative motion and you're getting some hang of it and how to go about the maths of it. Alright, so that is it for today. We'll discuss all this tomorrow because I'm running out of time. Alright, so that is it for today, guys. Alright. So before I leave you, let me remind you that you can get your Unacademy subscription by following these simple steps. Okay, you install, you go to the plus section. Once you've installed the app, you select your goal as IIT JEE and you click on the get subscription button. And also remember, while getting your subscriptions, you can use my code, which is RD Live. So use RD Live and you will get a 10% off in your subscription fees. Alright. The next class would be on Monday, Chinmay, at 4. Next class would be on Monday. So I'm taking classes for class 11 students on Monday, Wednesdays, Fridays at 4. For class 11th. Okay, in case you did not know the schedule. So this is the schedule. And in case you don't know the schedule, then you can obviously press the bell icon so that you're getting all the notifications of all the lectures. Okay, if you like today's video, then press the like button and share it with the friends. Okay, the PDF notes of all the slides used in today's lecture will be available for download later. Alright. Next, please don't forget to join us on the Telegram app using the link above so that you're getting all the notifications of all your lecture schedules in time. Now, before I leave you, let me remind you that you can use my code to get your Unacademy subscriptions. My code is RDLive. Use this code and get an additional 10% off. Alright. So I'll see you next on Monday. Till then, you take care. Go through this lecture and practice some problems on your own.